This is the Geometry Unit 7 Lesson 6 video, and this is over secant and tangent angles, and I'll kind of give you a rundown of what those are, and then there's a bunch of proofs that we'll do together, and I'll kind of tell you what you really need to know for the test. So just to kind of get some definitions out of the way, there are three main types of angles that you are types of circle angles you need to know about in this lesson. We've talked about central angles. Just to remind you, a central angle is an angle that has the center of a circle as its vertex. This would be a central angle. And then, of course, we had what we did last lesson, which was inscribed angles. Inscribed angles are angles like this one that have points on the outside of the circle. So these are the two types we've talked about so far. And then we are going to look at today, the first type we'll look at is going to be called a secant tangent angle. So secant tangent angle. And there's actually two ways this can look. One way is that you have a tangent line and a secant. This is a secant because it crosses the circle twice. This line is a tangent because it goes off and touches the circle just once. Or it can look like this. So you see again, these are both, this is a tangent line, and the other one that touches twice is a secant line. And so in both cases these are called secant tangent angles. So really on the test, what you have to know is, looking at a diagram, be able to identify these different types. So we have central angles, inscribed angles, and then secant tangent angles made up of a secant and a tangent. And then you also need to know about tangent angles. Tangent angles, both lines touch the circle in one place. So this is called tangent made up of two tangents. And then lastly, you need to know about, you can probably guess what it's going to be, secant angle. Secant. So on the test, you're really just responsible for being able to look at a diagram and put it in the correct category. So I'm going to put these diagrams in the notes, and that's really what you're responsible for. So the rest of this lesson is just going to be me going through the proofs and getting you what you need so that you can move on. And then the review, I'll kind of tell you more specifically what the questions are going to look like. So looking down here, they kind of ask you some questions. Just note the theorems here. You need to just use those theorems to answer the questions. That's pretty much what you're doing in numbers 2, 3, and 4. Then you have those diagrams like I just told you through number 7, and then there's a proof. But first we need to do this proof in number 1. Move this over here. So I'm just going to walk through this with you. All right. Given circle S with two secants, MO and NP that intersect in the interior of the circle at Q. So we have secant and we have secant. Okay. Prove that the measure of angle MQP is 1/2 the measure of the two arcs here and here. Okay. Well, we're going to just walk through this proof together. They've got our givens written down, and they've drawn an auxiliary line. You can see that right here. It's the auxiliary line they've drawn. creating a triangle there. That's just there are any 2 points, there's exactly one line. Anytime you draw an auxiliary line in a geometry proof, you're using what we call what we say as through any 2 points, there is exactly one line. Then they say that MQP is equal to QPO and QOP. So looking up here, that's referring to the following. That's referring to MQP is this angle, QPO is this angle, and that's using the exterior angle theorem. Because these angles down here are exterior angles of the triangle. Or sorry, MQP is an exterior angle of the triangle, and so those angles have to add up to each other. Then it says QOP is 1/2 of MP, and QPO is 1/2 of NO. They're taking each of those smaller angles and applying the inscribed angle theorem, because they are both inscribed angles. Here again, we're talking about this angle here and this angle here. They are both inscribed angles. So since this is an inscribed angle here, then it's half the arc, and this is an inscribed angle, so it's half the arc. And so they're finding the measure of those arcs. Then they are doing some substitution. You can see that pretty clearly. They're taking the information from number 3. It says from line 3. And they're doing substitution. They're doing substitution again from line 4. And then they're applying the distributive property. So anytime you're just dragging things down and replacing things, and it says like from line whatever, that's going to be a substitution. So make sure you got all that. Let's jump down to our other proof or proofs. Just one, thankfully. More of the same. We have circle P. It has 2 secants. It has secant AC and it has secant AD. And they intersect outside the circle out here. And they drew an auxiliary line. Like I said, anytime you draw an auxiliary line, you're talking about through any 2 points, there's exactly one line. And then they give us a hint here. These are remote interior angles. And so they're using the same property from earlier, the exterior angle theorem, to say that CED, which is this angle, is equal to the sum of these 2 tiny angles over here. That's coming from and then they're applying the inscribed angle theorem, just like they did in the previous problem, to say that the angles have this certain measure based on the arc. And then they're doing substitution. Same exact process as the previous one. And then they're proving, using arithmetic, doing algebra, proving that the angle is half of the difference of the arcs. So make sure you get all this down. Remember, you're not responsible for the proofs on the test. You are responsible for knowing which type of angle is being referred to in a diagram like these in 5, 6, and 7. The next thing you'll get from me is the review study guide and the lesson video to go with it. And we'll be testing next week. That's it for lesson 6.